having a radio transmitter and a radio receiver along with the channel. And we have seen in detail about the radio transmitter using both amplitude modulation and that of the frequency modulation. Right? So now we will see the other part of your radio communication, that is a radio receiver. So what does a radio receiver has to basically function? So what is that we are having at the receiver? A transmitted signal transmitted from a foreign transmitter, maybe at a distance of kilometers, and with a transmitter power of 1 kilowatt or 10 kilowatt or 100 kilowatt, whatever may be the transmitter power that we are going to have it. So at the receiving end we are having the received power. So what will be the received power that we will be expecting at the receiver? When you have a 10 kilowatt transmitted power radiated around 100 kilometers, so what will be the received power? So we are radiating in the isotropic way, therefore 1 by r square will be coming and so on. Therefore the received power that we will be having will be in the order of millivolts or milliwatts or microwatts. Normally we will be saying that we will be having a received power of, let us say, millivolts or milliwatts, or in terms of voltage you say that microvolts, the power voltage that we are going to have it. So when you have the power in milliwatts or a voltage in microvolts, your system will not be sufficient to have the signal to be displayed in the order of microvolts. Therefore we have to amplify the received signal to a certain level. Therefore any receiver we have to have initially a tune circuit to tune to the required frequency of the transmitter station that we are going to have it. Normally a medium frequency transmitter frequencies ranges from 535 kilohertz to 1640 kilohertz. So the medium band AM transmission will be having the frequencies ranging from 535 kilohertz to 1640 kilohertz. Therefore, suppose if you are choosing a station at 800 kilohertz, then your station or your receiver has to tune to this 800 kilohertz. We said that each AM station having a bandwidth of, what is the bandwidth of AM station? Bandwidth of AM station 10 kilohertz, because we said that it is plus or minus 5 kilohertz. Now we have the baseband signal audio frequency limited to 3.3 kilohertz with required broadband and so on, so that the adjacent channel signal or the transmitter signal will not be interfering with this. We said that each AM station will be having 10 kilohertz as the bandwidth. So we will be having, if you say that 800 kilohertz as your transmitter station, you want to tune it, that is the signal that you have to pass to your receiver is 795 to 805 kilohertz. The tuning range that we are going to have is 800 kilohertz, and the bandwidth of your amplifier should have 795 to 805 kilohertz, so that the total bandwidth is going to be 10 kilohertz that we are going to have it, so that we receive only the wanted signal or wanted station that we are having. So basically any receiver initially should have a tune circuit along with the antenna that we are going to have it, because the antenna receives all the frequencies from 535 to 16 kilohertz, but whereas your tune circuit at the input stage will be having a bandwidth of 10 kHz tuned to your 800 kHz. Therefore, the first stage that we require in your receiver is going to be the tuned circuit that we are going to have it along with your antenna. And the output of this tuned circuit, as you say, that it is in order of microvolts. Therefore, to raise this level, you require number of amplifiers. So we have to raise this signal. So we will have number of amplifiers, say 2-stage amplifier or 3-stage amplifier, depending on the requirement of the amplification that we are going to have it. Then after the amplification, we have to detect the signal, because we have the required modulation, AM or FM, at the transmitting end. Therefore, we require an appropriate detector at the receiving end after amplification. Again, the detector output will be again a reduced value because of the coefficients that we are going to have it. Therefore, in order to raise this to the level of your loudspeaker, 100 watts, 1 kilowatt or 3 kilowatt, whatever the power that you want at the loudspeaker, we have to raise this signal level. Therefore, again, what is the output of the detector? Output of the detector is message signal or your baseband signal, or we say the audio signal. Therefore, we have to have your voltage or the power amplifiers at the audio frequency stage. Then you have this to a loudspeaker or the system that we are going to have it. So any receiver should have basically these components that we are going to have it. So different receivers have been designed since the communication started, the electrical communication, and all this mostly the used receivers are tuned radio frequency receiver and that of a super heterodyne receiver. We have number of different options, but mostly used receiver types are tuned radio frequency receiver and a super heterodyne receiver. To say that even in this tuned radio frequency receiver and super heterodyne receiver, the mostly used one is super heterodyne receiver because of its all the advantages compared to your PRF receiver that we are going to have it. So instead of directly going to the operation of super heterodyne receiver, we will see that the operation of a tuned radio frequency receiver and see what are all the disadvantages that we are going to have it, so that we can say that all these things are going to be nullified or used in the case of your super heterodyne receiver. So that instead of saying that super heterodyne receiver having all the advantages, if you know what are all the disadvantages of your other receiver, we will be knowing what should be the advantages of your super heterodyne receiver. So a typical block diagram of your tuned radio frequency receiver, as I said, will be having number of RF amplifiers, because the input signal that we are having is, as I said, 800 kHz, the radio frequency signal. Therefore, we are having the required RF amplification input stage. So number of amplifiers with 2 stage or 3 stage, depending on the required level of amplification that you wanted. That has been given to a detector to detect the baseband signal. And all these things, the first amplifier, second amplifier, and the detector are what you call the gang tuning. All the capacitors combined and a single tuner we are going to provide, so that all these circuits are going to be tuned to the required frequency of operation that we are going to have it. So these amplifiers may be having a single tuned circuit or a double tuned circuit that we are going to have it, so that we will be getting the required elimination of the adjacent channel signals that we are going to have it. Compared to a single tuned circuit, if you have a double tune circuit, then you will be having a more elimination of the unwanted signals or the adjacent signals, but tuning all these circuits in a ganged way for all these amplifiers and detector with all these double tunes is going to be a difficult proposition that we are going to have, because when you say that the received signal that they are selected 800 kilohertz, all these stages have to tune to the required 800 kilohertz frequency. In the 10 kilohertz bandwidth that we are going to have it, and we don't have the tuning, then we may not be getting the required addition channel rejection that we are going to have it. Therefore, normally we will be going for a single tune circuit in the case of tuned radio frequency receiver that we are going to have it. And we are having the detector, AM detector or your phase discriminator for your FM modulation that we are going to have it. And output of this detector, as you said, that is audio frequency, therefore we are going to provide voltage and power amplification of these audio frequencies that we are going to have it. Then this output of this power amplifier is given to your loudspeaker to give our required signal in the audio way that we are going to have. From electrical, we are converting your signal into the sound signal that we are going to have. Or if you are not interested in immediately listening to this, going to a recording device so that you can hear this at a later time that we are going to have. The output of a power amplifier is connected to a recording device or a loudspeaker that we are going to have. So typically this is what a tuned radio frequency receiver that we are going to have it. But as you say that this we are not presently using. But what are the limitations of this tuned radio frequency receiver, so that we can see that these are the advantages that we are going to have it in our super heterodyne receiver that we are going to have it. So we are having the required signal in the microvolt. Then if you say that you want to go into the as output of this second stage or third stage amplification, what is the gain you require? The gain we require in these two stages or three stages. This is microvolts. Here I want an order of volts. What will be the gain that we require? Microvolts to volts. So this is 10.6. Some 40,000 and 50,000 that we are going to have. So that much gain you are providing to make this microvolts. The second amplifier to the have it. Frequencies you have a step up between the amplification states. Suppose if you say that we are operating in the short wave range, some 25 megahertz or 30 megahertz, those frequencies, any stray capacitance coupling will be sufficient. The output of your the input to this input of your amplifier. 1 by to the input. If this is in phase with the input, what will happen? If the signal that we are feeding through a coupling capacitor to the input of your first RF stage is in phase with your input signal, what will happen? Pardon? A feedback is given here from output of this RF, second RF amplifier to the input of the first RF amplifier, sufficient in phase. So we are having a what you call a positive feedback. So once you have the positive feedback, what will happen? If they are in phase and having a sufficient amplitude, then without any input from the antenna, this output of the second stage amplifier itself is sufficient to give the required output. Therefore, oscillation starts. Because all the amplification we are providing in these two stages itself are 3 stages in your tuned radio frequency receiver. Therefore, this configuration gives you when you are having very large amplification that we are going to have. Therefore, at shortwave frequency ranges, this type of receiver will not be a functional one that we are going to have. At low frequencies or medium frequencies, this may be operational, but at shortwave frequencies, this becomes unstable or likely to become unstable. Therefore, this is the disadvantage of your PRF receiver that we are going to have. Right? So the main disadvantage that we said is the gain that we are providing at this first stages is going to cause a feedback at the input. Therefore, this becomes unstable system. Therefore, without any input, we are getting the output. So oscillation starts, which is not required one. Whereas you have to use this receiver to detect the received signal. But there is no received signal, but still the output of this is going to give you some output. So you detect the output and out will be giving some unwanted signal or noise signal that we are going to have. Without any input signal, we are getting the loudspeaker signal that we are going to have, which we don't want it. So this is the disadvantage of your PRF receiver that we are going to have. Another disadvantage that we are going to have is, we said that we are going to have the tuned circuits, right? At each stage you have the different tuned circuit. Depending on the bandwidth and the center frequency, your Q has been fixed, right? Suppose if this input is 535 kilohertz, the station that we are tuning is 535 kilohertz, and your bandwidth is 10 kilohertz. What should be the Q value? We are having 535 kilohertz and so this is the Q value that we require, F by delta F. So what is the value required? 53.5, right? So the value that we require is 53.5 is the Q value that we want. So capacitor, your circuit can obtain this value, but the same receiver you have to go up to 1650 kilohertz, right? So that means your Q value has to change to 1640 by 535 to 164. That is 1640. At the lower limit, you are having a value, but higher limit, you require 164 as the Q value that we wanted. So at the lower end, 53.5 is no problem, but at the higher end, we the Q value of 164. A deep circuit. So 1640 by 120. So what is this value? This should come from approximately 13.5. So if you say 700 kilohertz, we are receiving is now up to 605, 595 to 605. We are receiving 607 kilohertz also. Whereas 607 kilohertz is 121. It's not. To itself, we are not able to obtain the required Q value in the case of our this that way. This is the limitation that addition. Rather, 600 is our signal, whereas this is a part of it, which is resonating with your original signal. Therefore, unwanted signal also comes. So what is the Q value that we require? What is that you want? To find 5 into and the part of it. Therefore, all your sideband, all additional channel signals be off your tuned circuit at those frequencies. Therefore, we can't go for the operation tuned frequency receiver. But that's it. Now, the transmitter signal is one megahertz. And tune this circuit to this 2 megahertz signal. The required and the variation of the capacitance is going to be having this is a fixed frequency. I can design a tune to have this required so that capacity is not getting display them. The simple one design. Except the one Q factor. but they are much inferior to operation of STR of this. Therefore, we are not going to. Yeah. Other. Yes. See that even this is not of practical importance for us. So this is what your the schematic idea of receiver and disadvantages that we are going to have it the other receiver. And main advantage is simplicity and design that we are going. That's what and then that the receiver we want some amplification because signal is weak, then it super hadron receiver that we are having. So this is the block schematic of super heterodyne receiver that we are going to have. This one we are having basically RF stage along all the individual components that we are going to have it, and the output of this RF stage is going to be a mixer which after when we are having the input signal that we are going to have it. So when we have this mixer, what will be the output? The input signal of input signal not combination of these two, the plus or minus. So we are choosing a two circuit here to select the difference.
ప్రపోజల్ మనం డ్రాఫ్ట్ చేయాలి కదా సార్, అంటే జస్ట్ మనం ఇది చూసి ఏమేం కావాలో ఎంత మెటీరియల్ పడుతుందో అని చెప్తారు సార్. అది ఇన్కార్పొరేట్స్ మిగతా ప్రపోజల్ మనం డ్రాఫ్ట్
and this is amplified in the
మొన్న ఆ రోజునే ప్రిన్సిపల్ సెక్రటరీ వచ్చిన రోజునే నేను ఇమీడియట్ గా షెల్ నోటీస్ ధర్మని చేశాను కాబట్టి వాళ్ళ ప్రపోజల్కి నాకు టెక్నికల్ స్పెక్స్ ఇవ్వను సార్. అంటే ఇప్పుడు మనం సర్వర్స్ కూడా ఏం చేసి ఇవ్వడం సార్ కొనేటప్పుడు
the low frequency having 1000 plus the intermediate frequency, so that again difference frequency is only
చాలా హై అండ్
this sample this
తీసుకుంటారు సార్ వాటి వీళ్ళు కూడా ఇవ్వరు. దే కనెక్ట్ టు సిస్కో కంపెనీ డైరెక్ట్
means
మనం రాజుల గారు వచ్చినప్పుడు తీసుకోవాలంటే సిస్కో పార్ట్నర్కి ఇది కూర్చొని సిస్కో దగ్గరికి వెళ్తారు అప్పుడు సిస్కో ఫైనల్ స్పెక్స్ అన్నమాట కంపెనీ ఏం చేయాలి దానికోసం జస్ట్ టాపాలజీ ప్రపోజల్ అవి ఉంటే కనుక ఈ పార్టీ మినహాయించడానికి సార్. ఒకసారి మీ దగ్గర పంపనా సార్? అదే సార్ అందుకోసం ఒకసారి తను పంపాను సార్. అదేంటి పోనీ వాళ్ళు ఏదో వెళ్ళి ఒకటి రెండు చోట్లకి తీసుకుంటారు సార్. వచ్చారు సార్ నుంచి వచ్చారు, వెయిట్ చేశారు. ఇవ్వమని చెప్పాను సార్. సార్ రిజిస్టర్ గారు కూడా చెప్పాను సార్, ఇప్పుడు వస్తారు వచ్చినప్పుడు ఇవ్వండి. వీకెండ్కి ఇవ్వాలి కదా సార్, మరి ప్రపోజల్ ఇవ్వాలంటే హాస్పిటల్
input output is back
లేదు సార్ ఆవిడ నాకు నేను మార్చి 3rd 4th నేను ఢిల్లీ వెళ్ళాలి సార్ ఈ ప్రజెంటేషన్ కూర్చొని నాకు ఆ డేట్ కూడా ఇచ్చిందండి. ఇదే కాదు ఎగ్జిక్యూటివ్ కూడా మొన్న సండే అంతా కూర్చొని యూఎస్ 33 కోట్ల ప్రపోజల్ 17 కోట్ల
is connected to
ఈ మూడు కూర్చుకుంటే డిగ్రీ నన్ను పంపిస్తే ఈ ప్రజెంటేషన్ అయితే కనుక
they will not be any
ఢిల్లీ రమ్మంటే ఇప్పుడు వెళ్ళి ఇస్తాను 31st కి బడ్జెట్ లోపు అమౌంట్ శాంక్షన్ చేయించాలి.
that frequency is different from
బిఎస్ఎన్ఎల్ లేదు సార్. ఇప్పుడు ఏంటంటే ఈ ఇందులోనే బిఎస్ఎన్ఎల్ మనకి లాస్ట్ 3 ఏళ్ళు తిప్పారు సార్. అలా బిఎస్ఎన్ఎల్ కూడా చెప్పాము సార్ ఇలా ఉంది ప్రపోజల్, దీన్ని దానికి లింక్ చేయించి మీరు డైరెక్ట్ గా వాళ్ళ చేత చెప్పించినా సరే లేకపోతే అది వదిలేసి సెంట్రల్ గవర్నమెంట్ మనీ ఇప్పించినా సరే అడగండి సార్. ఆ సర్వే ఇంకా రాలేదు సార్. అది వాళ్ళు చూస్తారు సార్. అంటే వాళ్ళు స్మార్ట్ క్యాంపస్ కి చేయలేదా సార్? ఓన్లీ మనకు ఉన్నదాన్ని స్మార్ట్ క్యాంపస్ కంటే ఇంకా ఎక్కువ బ్యాండ్ ఇంకా హై అండ్ ఎక్విప్మెంట్ కావాలి సార్. దిస్ ఇస్ డిఫరెంట్ అండ్ దట్ ఇస్ డిఫరెంట్. దాంట్లో పార్ట్ కింద అది వస్తుంది. అందుకే వాళ్ళు చేసేది ఏంటో వాళ్ళని అడిగి అది ఇంటిగ్రేట్ చేసి దాన్ని అప్గ్రేడ్ చేయడానికి కూడా పనికి వస్తుంది సార్. పంపిస్తున్నాను సార్.
September plus we are having a big so that we are going to provide from yeah, fine. Fine. So, if you have your baseband signal, now what we are doing is we are fire up. Send around FC. Up around. We are changing to on. Timo. On. Down to that. Jawab. We are having. So this is what and here going to have the required to have it so that your problems also will then we'll see that how the so basically as we said that your output of the detector is going to how does signal that have it using AM modulator, AM detector or FM discriminator. Therefore, any community there was this
చేస్తానంటే మూడేళ్ళు చేశారు ఎన్కేఎం కూడా కానీ బిఎస్ఎన్ సర్వే కూడా చేశారంటే అవ్వచ్చండి అదేంటంటే మన క్యాంపస్ మామూలు దీనికోసం మనం స్మార్ట్ క్యాంపస్ పెట్టుకోవాలి అంటే కనుక దాని రిక్వైర్మెంట్స్ వేరే ఉంటాయి సార్ దానికి ఇంకా హై కావాల్సి వస్తుంది ఎగ్జిస్టింగ్ పాయింట్స్ అంటే ఎక్విప్మెంట్ ఏంటో తెలిస్తే దాని నుంచి మనం ఎలా చేసుకోవచ్చు అన్నట్లు వాళ్ళు ఇస్తారండి.
But what? This is your FI, the input signal that you want to choose. And on your cover and receiver, you have to generate a localized frequency F0. So this will be our FI plus FIF. And this FIF same transmission is going to be 4.5 kilohertz. We see how this 4.5 kilohertz at that stage. Therefore, value
కానీ అది ఇచ్చి లేదో మాకు దీనికి సరిపడగా ఇవ్వండి అని నేను మాట్లాడడం కోసం ఉంటుందండి
which is
లేదా
on a device.
తొందరగా ఇవ్వమని అంటాను లేకపోతే వాళ్ళు ఇచ్చే వద్దు మేమే ఇస్తామని ఇంకోటి తెచ్చుకోమని
8 kilohertz and 55 kilohertz
ఆ పనులన్నీ కూడా దాన్ని బట్టి
have been given as the inputs to your mixer. Inputs you are giving to your non-linear which is going to be having a non-linear operation a square law or much higher order also. Therefore, what will be the output of your mixer? Your 800 kilohertz, your 1250 kilohertz. The difference is frequency, and we are tuning or having a circuit at the mixer output. The output has me the difference frequency 12 kilohertz without kilohertz plus or minus 5 kilohertz that we have around that 450 kilohertz that we have. That means if your IF output is tuned, the mixer output, all the required modulation on this 450 kilohertz airport. Okay? Then we are having this frequency. Converts back to చిన్నగా అయితే సెంటర్
ఒకసారి అంటే మనం దాని ప్రకారం వెళ్ళిపోవడం కాదండి.
So this of our detector so that yeah point
నేను ఇప్పుడే ఏంటంటే వచ్చి చూసి అతనికి మీకు ఫోన్ చేసి చెప్పి
that way are going to have it. With minor modification, depending on the requirement and the model, so this ever is going to be there. Radio communication that way. Okay. Yes. So here, go. And 4 kilohertz. This has been because you want to have the required amplification also. The required variations are going to have it. We prefer so heterodyne this. So instead of we're going to have about the area receiver and see what are all the variations that are required in the case of AM receiver. All these things that we are going to discuss is having amplitude. So you have a limiter to eliminate the amplitude variation that we are going to have for this receiving. Whereas in the case of AM, you can provide a limiter. If you provide a limiter, the loss and your antennal will be lost. Therefore, you can't this method to give you a frequency to amplitude. Base band variation. There. I will discuss more in detail about AM and receiver that we have. Then coming again, we'll have your antenna system that we are going to have it similar. And this is given to the RF stage. So this is one station we are going to have. Station of the capacity are tuning the and range of 16 Therefore, your basic requirement core, inductor core we have in capacitor. Yes. Along with that, required signal also is going to be induced onto your fast degree as possible. I fast then more also we can design the one on the yeah. This RF section, the input that we are going to have, having enough. So, along Jntuk the RF amplifier also, and the front should be designed as very low noise amplifier. Have to increase this. So cost of this but therefore a local will not
ఏంటి సార్ హలో
right?
ఓకే సార్ ఓకే సార్
Once you say that along with your tune circuit, what does it mean? That we are having other amp. Now the audience is coming out without the mixer. If we have a gain of 100 at the other amplifier, so one may output into 0.1 volt. The sensitivity increases. Let us gain, which utilize better sensitivity. It is at the real contact. Now that means you have this.
ఇప్పటిదాకా శాలరీ అంటే మొన్న ట్యాక్స్ అంటే
Most
ఒకసారి శాలరీ స్టేట్మెంట్ ఇవ్వాలి
that means of 100 minutes
శాలరీ స్టేట్మెంట్ ఫైనాన్షియల్
one
ట్యాక్స్ కట్ చేసింది రాస్తున్నాం
to be issued by this. They were having RF amplifier. That's still they are going. And providing what you call impulse image sequence rejection. Image sequence rejection. Yeah, I'm going to the gain that happens. Hello, Doctor. That is what you have it. Yeah. Double circuit also will be provided here. That guest is to be there. We are going to provide signal so that signal to noise going to we reduce having higher
ఇప్పుడు బయటపడ్డామండి
gain
అంటే ఏం లేదు
of other.
ఏం లేదు ఏమైందంటే అంటే బీసీ గారి దగ్గర ఉంది
Then I will say more than
వచ్చారు సార్ సాయంత్రం సార్తో
increase the
అది మళ్ళీ వచ్చేసారు మళ్ళీ తెల్లారి పెట్టండి సమాచారం మళ్ళీ వచ్చేసి
supply is
మధ్యలో ఏమైందంటే
that it is just analysis. These are degrees.
కలెక్టర్స్ కాన్ఫరెన్స్ 20 నుండి 23 అవుతుంది
Other fabric.
సో అందుకనేమో నుంచి సార్ ప్రజెంటేషన్స్ అన్ని రెడీ చేయాలి అయితే పొద్దున్న సడన్గా సునీత రావడానికి ఫోన్ చేసి ఎంతో రావట్లేదు ఆవిడ ప్రజెంటేషన్ కూడా తీసేయాలి
Hello.
సో మొత్తం ఇది సంబంధించి కానీ పెట్టిన పొద్దున్న ఫోన్ చేశారు మొత్తం అన్ని రెడీ చేయాలి
So that we are going to have it.
చేసింది నేను 2-4 బయటపడ్డాను వచ్చాక వేరే వ్యవసాయం పేపర్ ఇచ్చి ఇప్పుడే జస్ట్
What is?
జస్ట్ కాల్
Sex. We are going to have a coupling and especially at the frequency. Other one day saying the village now.
నేను పొద్దున్న నుంచి అదే చేస్తూ దాంట్లో దున్నుకుంటూ అలా ఉన్నాను
Sequence.
నాకు ఈ లోపల ఏంటంటే మేడం వెళ్తూ నాకు చెప్పింది ఆవిడ మొన్న ఢిల్లీలో గవర్నమెంట్ ఆఫ్ వాళ్ళతో మాట్లాడింది
Other council
ఐటీ సెక్రటరీ
included in the one.
ఎగ్జిక్యూటివ్ ప్రపోజల్ పెట్టండి జస్టిఫై చేసి
You say that other
ప్రాపర్గా సెపరేట్ చేసి పెట్టండి అని చెప్పి అన్నారు
may be having
మేడం నాకు
Yeah.
దాన్ని స్మార్ట్ క్యాంపస్ అంతా ఈ వీకెండ్ లో ప్రపోజల్స్ రెడీ చేయించండి నేను నిన్నంతా 2 hours బర్త్డే ప్రొఫెసర్ ఒక ప్రపోజల్ ఒక షేప్ తెచ్చి 33 కోట్ల నుంచి 17 కోట్లకి డిజైన్ మెథడాలజీ వాడదాం ఎలా వాడదాం ఏం చేద్దాం అనుకుంటా తయారు చేసి ఒక్కొక్క షేప్ తెచ్చి దానికి ఇంకా 2-3 రిఫైన్మెంట్స్ ఉన్నాయి మరి షెల్ నెట్వర్క్స్ వాడు ఇవాడు వచ్చాడు
frequencies.
బుధవారం మన సిటీ వాడు వస్తారు సార్తో ఏంటంటే ప్రపోజల్ పెడతానంటే
The local
ముందర ఈ క్వాలిటీకి తయారు చేద్దాం అనుకున్నా కానీ సార్ ఈ క్వాలిటీ చూసి పరిశ్రమ మేడం అనేది కలిపి ప్రిపేర్ అవ్వాలి మళ్ళీ ఐడెంటిటీ మళ్ళీ వేటితో ప్రిపేర్ అవ్వాలి
and now they did again.
అంటే నేను ఏం చేశానంటే నేను తయారు చేసి సాయంత్రం సార్లు అయిపోయాక ముందర ఓకే
And they say, amen.
అవునవును అవును నేను మధ్యలో నేను 2 రోజులు
Coming out. They put that because they do it as
చేయగానే ఇమీడియట్ గా పొద్దున్న 10 to 12 15 వీడియో కాన్ఫరెన్స్ అయిన తర్వాత మళ్ళీ మధ్యాహ్నం ఇక్కడికి వచ్చాము వచ్చి సార్ ఏమో ఇమీడియట్ గా పిలిచారు అవుతుంది సార్ చెప్పారు రాత్రి 8:30 అయింది మళ్ళీ పొద్దున్న నుంచి మీది నేను చేసి ఏం చేస్తానంటే మామూలు మొన్న రాసిన లైన్స్ లో ఇంచుగా నోట్స్ పైన చేస్తాను చేసేసి దీనికేమో మీకు కావాల్సింది
at all.
అదే మీకు ఎన్ని క్లాస్ రూమ్స్ మీకు ఎన్ని క్లాస్ రూమ్స్ కావాలి 5 MBPS ఉన్న నెట్ ప్రొవైడ్ చేయాలి నెట్ క్లాస్ రూమ్స్ ప్రొవైడ్ చేయాలి అంతే కదా అది మేము రాస్తాం ఇలా ఇంత ఫైనాన్షియల్ కమిట్మెంట్ అడ్వైజ్ and you have given a commitment to bring 3 startups minimum by this time. Your planned schedule is this time అని చెప్పి రాసేస్తాను చేసి నేను ఇప్పుడు ఇవాళ ఈవినింగ్ లోపు నేను పెట్టేస్తాను
At the both
no problem.
I'm going to have it. But a low cost will not have gain that way. Yeah, I'm going to have it. Okay? I'm going to have it. The fast capacitors are made up of around what is that they are going to have. This is the beautiful capacitor that we are going to have it, and this one. And these things. What we are going to have it is, we are having a head like this. On it. So this is what we say that feed to capacitor at this shock wave that we are going to have variable capacitor. We have to the wall. Let's go. By itself. Okay. Either medium. Medium. Oh gosh. Have it? Next. Wait. We have the So you have, I'm having a you have this which one is one? How do you do? And then image frequency on that way. Okay, so sensitivity and this we don't have it. State the sensitivity has the relative is 5 volts or 5 volts so on. Then we that after this we have out to and we say that they have heads to the back as you know but this duty receiver and then measure put this resistance to be and going to provide this me and the get 15 as output when this is the input that required we are now you as output I'm going to have you have one minute this in to give you a stand and then it requires output that we have one hand. For the end, on my phone. as a these three are 12.7 microvolt. And this is 12.7. So we'll be having right? Then you see that getting site as an station. Then while pressing that, you replace with the dummy and the then put like more that see that change. But when maintain the system, the start with 30%. Then again, yeah, two. After 600 and then on. So this is our atypical. Yeah. Okay. Right? So this is what your sensitivity consists of. Right? AM receiver, sensitivity. Depends on application. Different radios with the different amplification of the stages that we have to have it. So that's what your sensitivity. The other one that is said is selectivity. Adjacent channel rejection that we are going to have it. That is, again, we state or define the selectivity as the ability of your receiver to reject the signal or unwanted channel. The ability of the receiver to reject unwanted we want? Suppose if
నమస్తే మేడం
now you tune that
చెప్పారు కదా ఒక
5 kilohertz away,
ఆయన పేరు పార్థసారథి గారు
or change your transmitter frequency to 5 kilohertz away. 805 you make it without changing any of your tuning circuit. Your receiver is maintaining the tuning of 8 kilohertz only. You are changing your received signal instead of 800, you have put it 805. What is happening? Because you are having a tune circuit, the output will be reduced. Now what we are doing is, see that 30% is maintained constant, and see that you are getting 50 milliwatts again at 805 kilohertz. Measure that value, because that value is much high. This minimum value. That's why we are having more than that way. We are going to have it. And it can you make it the signal. Cannot change receiver to station.
అలాగా సరే సరే మేడం మీరు తెలుసుకుంటాను నేను దాన్ని బట్టి
And so on. But different give us June your receiver to 800 kilohertz only.
అంటే అది గవర్నమెంట్ కదా ప్రైవేట్
That you don't.
వాళ్ళ దగ్గర ఎక్కువేమో కదా రేట్
The frequency, you require more power to get this.
సరే
So at plus or minus 20 kilohertz, typical. Plus. Minus. Defensive. Call. Now the noise ratio. Good. What? Just how they pretty much this differential from this how and then go on. Now that the so, I think they'll lock who's this? Because now I'm
అయితే అలాగైతే ఆవిడ వెళ్ళిపోయింది ఆల్రెడీ సో నేను
Yep. RF.
She is in US.
Do you have right?
మన ప్రపోజల్ మన క్లయింట్ నుంచి అండి మన క్లయింట్ నుంచి అండి
Is F S plus Fi. That means you can think this F S and F not. S and F are we are this F S and is to again only because F not this back. Good. This signal is F5. Yes, it's not F5. This F is F0 minus Fi because this is F0 and this is Fs. It's not Fi. So you are mixing these two, difference between two inputs, F0 minus Fs. That's what we are having. F0 minus Fi is going to Fs. Okay, that's the signal, put signal that we are going to have. It is F0, Fi, and localized it is F0. So F0 minus Fi gives you the input image frequency. The intermediate frequency is Fi that we are having. What is that? Suppose if here we are going to have this Fi F and Fs side the image frequency it pass to the mixer here you can differentiate the image frequency is intermediate frequency is coming because of your signal frequency or image frequency you can't distinguish. That means two signals of different with the same frequency.
Okay, ఇప్పుడు ఇస్తాను 2 నిమిషాలు అని చెప్పి
and amplified detected and so on, then you are going to get as a one about health issue. Now for the farmers in some fluctuations we are not using same time that we have got that. Whereas the oscillator frequency is going to be in frequency plus the intermediate frequency that we have. So we are defined as the gain signal. See, by gain at the image, that is
WhatsApp lo పంపండి.
gain at image frequency, that is gain at FSI. The ratio between these two we call it as the frequency rejection that we have.
Related to number 1 in this line అండి. నేను డౌట్ వస్తే మళ్ళీ అడుగుతాను సార్. నా పేరు జేవిఆర్ మూర్తి అండి. ఈ నంబర్ని మీరు వాట్సాప్ చేసేయండి నాకు వచ్చేసి.
That the put that way. So this where this value is given as FSI by Fs, that is image frequency by the signal frequency. And thank you. Load. The load. So, if you of that will be Q that we have used in this expression. After the short wave frequency, this will be giving you very low value. Then you say that you have signal frequency as 800 kilohertz. So, this this is 1710 by 800. Okay, this is 2 point, and this is Fs minus Fi. This is going to be 800 by 1710, point half, 1 by 2 that would have it approximately. So this one can be regulated so that half is equal to 120 approximately. Whereas if you say that signal frequency is 20 megahertz, so what will be the image frequency? 20.9, 20 megahertz plus 0.9 megahertz or 910 kilohertz. So 20.9 by 20. So this is 1.04 by this is 20 by 20.9. Again this is 9 also. So R value minus fine. So 0.1 square, this is 75 whole square, 75 into 0.1, 7.5 whole square. So for the same tuned circuit, alpha value for short wave frequency is going to be much less compared to medium wave frequency band that we have. Yeah. Frequency rejection is going to be a typical problem in the case of short wave range of operation that we have. Whereas there should not problem. So we have to this and about short wave. What we call double spotting. We'll use the image frequency for design identify what is the signal that has been sending from the transmitter. Suppose you have so it is and this is no. By using this double spotting, we can identify when you are doing this, you are receiving this signal 14.7 megahertz, you are 2.0 megahertz. Suppose another station which is somewhat weak at 13.79 megahertz. We have another station 5 is your cause frequency when you have tuned your receiver to 13.79 megahertz. But simultaneously, you have this 14 megahertz also, which is very, very strong signal. Maybe 30-40 dB above the 13.79 megahertz signal. If you mix this 14.5 megahertz with this 14.7 megahertz, again you are going to get 450 kilohertz only as the intermediate frequency. With this 13.79, with this F0, when to input signal frequency. But when you are tuned station, because frequency is just getting this frequency. Whereas your station, strong station, which is at 40.7 megahertz. When you mix these two signals, 14 and 2 and megahertz, just 5 of only. Now, so when they are tuned this 15 and 45 55 megahertz. Yes, 40.7 megahertz. And when you are tuned your local oscillator to 4.7, 4.7. Yes, same state. Are you getting it? When you are tuned to this 15.15, 15.7 megahertz, you are getting the signal. When you are tuned this to 13.7, and also you are getting 14.7 megahertz, because frequency of the further line is with the part is again 455 kilohertz only. That means this 40.7 signal this two is 14.7 my the 13.7 the first part frequency and find the difference. Yeah. So this